Okay, 6-1 slope fields in Euler's method. I once had a college professor that said they locked up their computer because that's when the department had one computer. I'm old. And they locked up the computer, and when people say, what's the password to get in the computer? They'd say Euler and walk away. And if I told you Euler, how would you spell Euler?
O-I-L-E-R.
Okay, but
L-E-W-R.
Okay. But Euler is E-U-L-E-R, so no one could ever get into the computer. Huh? Okay, anyway, so we have looked at slope fields before. We've talked about them because slope fields give you general solutions to find particular solutions. And so we are going to actually construct our own now. So that is what the graph paper in front of you is for. So not right this second, but it will be. Okay. So a differential equation is y equals y prime x plus b. So a slope-intercept form is y equals mx plus b. Yes?
Yes.
But this is linear. But this is not linear, is it? That is that instantaneous rate of change, that slope function of the function. That's the question that's been on every test so far this year, except for our limit one. And I'm hoping one of these days you guys don't freak out when I ask you about the equation of the tangent line, because that's it.
Y equals mx plus b?
No.
Oh.
Y prime, because that's our instantaneous rate of change, correct? So a general solution to that is y minus y prime x equals 0.
I'm listening.
So I subtracted over the y minus x, and my y-intercept became a what?
0.
0. So that's how I went from the differential equation to the general solution. So we will start today off by verifying if things are general solutions. We got this? We good?
Yep.
So it says, is the function a solution of the differential equation y prime minus y equals 0?
Is that double prime?
Yep, that's double prime. So that means what derivative? The second. Okay, so our first example is y equals sine of x. So I need to find what?
Oh, wait a minute.
What?
I'm just...
She said, hold on, wait a minute.
Okay.
You need to find the second derivative of sine.
So in order to find the second, I have to find the
First.
first. So y prime is what?
Cosine x.
Cosine x. And y double prime,
Negative sine x.
negative sine x. So I now need to check if y double prime minus y equals 0. So I have negative sine of x minus sine of x. Does it equal 0?
No.
No, because it equals what?
2 sine.
Negative 2 sine. So we write negative 2 sine of x does not equal 0, does it?
No.
Okay, so it is not a solution of that, is it?
No, it's not.
So y equals 4 e to the x. So y prime is,
Sorry, I'm just...
that's okay.
I was like too busy. Y prime would be negative 4x.
It'd be negative 4
Oh.
e to the negative x. Because remember the rule for exponential is u prime times e to the u?
Yep.
Uh-huh.
Yes?
Yep.
And u would be negative x. So the derivative of negative x is?
Negative 1 over x.
Was negative 1. And negative 1 times 4 is negative 4. So now I need double prime. Well, negative 4 is there, right? So we're still doing the u du. So u is negative x. The derivative of negative x is
-1.
negative 1. So negative 1 times negative 4 is
4.
4. So it's 4 e to the negative x. And so now what do I do?
Now you have to subtract it.
I have to subtract it. So I have 4 e to the negative x minus 4 e to the negative x. And does that equal
Yes.
0?
Yes.
So 0 equals 0. So y is a solution, yes?
Yes.
So y is not a solution. I should have done that before, sorry. And if they are equal, y is a solution. So you try the next one.
Oh.
C is just a constant.
Good luck, Sadie.
That's supposed to be.
C is just a constant. Any constant.
Done.
Done.
So did you find y to be a solution?
Yes.
Yeah.
Okay. Was it hard to deal with that C?
No.
No?
No.
Okay, so what this tells me is if I have something of the form of y equals c to the ex, no matter what c is it going to be a solution?
Yes.
Yeah.
Yes. Now, you do notice this x is not negative, correct?
No.
I noticed that.
Okay. So if it's negative, it could be, but like what if I had y prime minus y equals 0? Well, if I had y prime minus y equals 0, would this be a solution? Because that would be the first derivative, correct?
Yeah.
So if I took the first
No, it
derivative,
wouldn't.
it wouldn't. Because it would be negative 8, wouldn't it? So you've got to be careful when you're just assuming and work it out.
Yes. No. Very soon.
Okay, so we have the general solution of y equals c divided by x, or c times 1 over x. That is the black line here. Well, the dark black is if c is 1. The lighter is if c is 2. If c is negative 1 and 1. See how it's going to change that equation? Okay. This is just the basic parent function for a rational function. That 1 over x that we've learned, that we've seen before. And we're changing this 1 to be different c's. Okay, solution curves are y, or x minus y prime plus y equals 0. Those are our solution curves. Remember we discussed particular solutions of differential equations, and we obtained initial conditions. We're going to do all that stuff again.
Wait, so do we need to write that bottom?
That's what was on the first slide. You guys were all writing, so I just was. Isn't that exactly what was on the first slide? No, it was not. Never mind. You do want to write that. sorry. Solutions of this curve are x, y prime.
But it's only for that.
Yes, it's only for this one.
So like
Yes.
for the parent function?
Yes. Yes, this is only for this graph. It's getting horrible. You guys done?
Yeah. What happened to the rest of the puzzle pieces? Are they all up there?
Mm-hmm. Okay, for a differential equation, x, y prime minus 3y equals 0, verify y equals cx cubed is the solution. Find the particular solution determined by the initial condition y is 2 and x is negative 3. So first verifying is what we've been doing, correct? Okay, so we have, this is y, we need to find what?
That's y prime.
We need to find y prime first, right? So I have y prime is going to equal what?
3cx2.
Okay. Sorry, my brain just... So 3cx squared.
Yeah.
Okay, so we also need to figure out what c is, don't we? If I have a y and I have an x, can I plug it into this equation and find c?
Yeah.
Yeah. Okay, so I'm going to plug it in. So that means 2 equals c negative 3 cubed. So what's negative 3 cubed?
Negative 27.
Negative 27. And I would divide that over, wouldn't I? So I have 2 negative 27c. So c equals negative 27 over 2.
If it's y prime equals. Never mind.
Are you good?
Well, I was gonna say, because didn't we plug in 2 for y, but it's still y prime?
Well, we plugged these into our initial equation, not into our y prime.
I see.
Not yet. Okay? So we found y prime was 3cx squared, but do we know c now?
Yes.
Yes. So now we need to plug in what? C.
Yep.
So a 3 times negative 27 over 2x squared? Yes?
Yeah.
So what does that go to?
Well. Huh?
What do I have to do now?
You have to find y. Oh.
I have to verify this, yes?
Yeah.
Okay. So it has x. What's x?
Negative 3.
Negative 3. Y prime.
3cx squared.
Can we put negative 81? Y'all good with that? I don't know why I didn't multiply that out. Because 3 times 27 is 81, right?
Oh, I see.
X squared minus 3y equals 0. Well, we need to plug in what again? and
X.
x. Okay, so x is 2 squared is 4. Minus 3 times, oh, wait a second. I plugged a y in for my x. Sorry. X is negative 3 squared is what? 9? Okay, and then y is 2. Okay, we want to do 9 times 81 or 3 times 81?
Well, either way. Let's
do
do
both.
3 times 81. So we can get rid
For
of
some reason, I'm feeling that we shouldn't have plugged in. Because it feels like we're doing it too much work. Does that make sense?
Yeah.
So let's come back here. You don't need to erase yours. But let's come back and do this equation right here with just y prime here in the original. Does that make sense what I'm trying to say? Okay. So we would have x times y prime, which is 3cx squared.
Yeah.
Yeah? Minus 3 times y. And what's y?
CX
cx
cubed.
cubed equals 0. You see why I said come back here?
Yeah.
Because this is 3cx cubed minus 3cx cubed equals 0, and 0 equals 0. Was that much easier to do? Yeah. We could have done it the way we were doing it, but were we making that really hard? Yes? Yes, yes, yes. So, oh, you guys did not catch what I did over here.
Huh.
Okay, well,
Look from here to here what I did. What did I do?
you should have.
Well, you have to divide it, get rid of the C first.
Well, no. I've got 2 equals, horrible equal sign, negative 27c. What should c equal?
C should equal.
Come on, guys.
Oh, wait.
This is like
I know!
I don't know.
Well, if you're trying to get
2
that's
equals negative 27c. How do you solve for c?
You have to divide.
By what?
Negative 27.
What did I do?
Divided by 2.
I divided by 2.
That was really tough.
I know. I'm like, come on. What did I do?
It's just kinda
It's just, it's Monday.
Okay.
yeah.
So I should have had negative 2 over 27. Was the other reason the other stuff was just not falling apart. Okay, so if c equals negative 2 over 27, so all I need to do is plug c. Since it is a solution, I just plug c into what? My general?
Yeah.
So this was my general. So what is my particular?
2 equals.
Y equals, what's c?
Negative 2 over 27.
Negative 2 over 27. So negative 2x cubed over what?
27.
27. Okay, remember solving for that c before when we found particular solutions? We're going to have to get back into the swing of that. And obviously do your math correctly like I didn't.
Okay.
Okay. Okay, slope fields. See if I can get a picture. Okay, those are slope fields, remember? Remember those?
Yeah.
Okay, so when I have the description of these, this is what you're forming in your brain. So, this is the process. Each line segment has the same slope as the solution curve through that point. So in other words, each line segment has the slope of the tangent line at that point. So how do we find slopes of tangent lines? We find the what?
The tangent.
We find the derivative.
You find the derivative, and then you plug in the x and y and get your particular solution.
Yeah.
Okay, the purpose of a slope field is show the general shape of all the solutions that can be helpful in getting a visual perspective of the directions of the solution of the differential equation. So, what I mean by that is, do you see how if I start at this point right here, I'm going to do what? Come down and then go where?
Up.
Back up. Do you see that? If I start at this point here, I'm probably going to go down.
Oh, you're just going straight down.
I'm not really going straight, because if I straight, it'd be middle one. Or I'd start here and go where?
Just go
That way.
That way. Do you see how you see those lines?
Yes.
Okay, this one goes like this, doesn't it?
Yep.
And I'm changing those by changing that XY. Okay. So, let's come back here. Says sketch a slope field for the differential equation y prime equals x minus y. So they found the derivative already. So again, the derivative is that instantaneous rate of change. It's the slope, correct? Mm-hmm. So this is my slope function right here. It's my slope function. I now need to find the slope at 1, 2, 3 points. Am I clear?
Yeah.
Okay, so my first slope, actually let me write my point so we know. So my point is negative 1, 1. I'm plugging it into my general solution to get my slope. So at negative 1, 1, y prime equals x minus y. So it equals what?
-2.
Negative 2. I know this is hard. So this is the slope of the tangent line of well, I messed myself up. Of the equation at negative 1, 1. That's all that means. So then I have the next point is 0, 1. So y prime equals x minus y. So the slope at 0, 1 is what? Negative 1. So then I have 1, 1. So y prime of x minus y equals what? 0. So what happens? Okay, there's my coordinate plane, yes? So my first point was negative 1, 1. So negative 1, 1. There's my first point. My second point, okay, my second point is 0, 1. I should have made it a different color, right?
Yep.
Okay, 0, 1. And my next point is 1, 1. Yes? Mm-hmm. So, my slopes at those points The first one is -2. So -2 goes down, yes? What you do is you just draw a mini line. -2. If that is -2, what does -1 look like? Is it as steep or less? Less. So -1. See how it's less steep than the one before it?
Yes.
Okay. And what is 0?
None.
So it is straight line. Now, that's how that works. But we did 3 points, correct?
Boom.
And if we need a slope field, we need a lot more than 3 points.
Oh my god. Let's go.
Okay? So we need all those points. So if you look at this, this is one, oops. Slope fields are a little time consuming. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So to generate that, they had to make how many slopes?
81 slopes.
81 slopes.
81.
Okay, we will be using tables in our calculator to calculate those slopes.
How about on the test?
We will be using calculators to calculate those slopes.
How am I supposed to know?
Now, you will need to reproduce your table for a little bit on your test, but then you reproduce your whole slope field. Make sense? So, identify the slope field that matches. So we need to pair these up.
Okay. Okay.
Yes, ma'am.
Got it.
I don't know if I needed to show you this. Or like, I got the A scholarship for this semester class.
I don't.
I don't know if I needed to show you it.
No, you
but-
don't need to show me. I would just a second. Let me